La 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 la. La 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 la.
Welcome to this channel. In this channel, lecture videos for theory courses such as fluid and particle mechanics, chemical process calculations, mass transfer, biochemical engineering, and fuel cells and batteries are uploaded. And demonstration videos for laboratory experiments in fluid and particle mechanics laboratory and chemical reaction engineering laboratory are also uploaded. Last year, we have uploaded 10 experimental videos, demonstration videos for FPM laboratory. So this year, we have procured a new equipment. And in this video, our student volunteers and our faculty along with me, Dr. Vidyasagar and Dr. Vijusmita are here to explain one of the interesting experiments in this FPM laboratory.
Hi everybody, welcome to Lion Rajmohan sir's channel. Today we are going to learn about a new experiment which is the discharge through notches. So we all know that previously in the last semester in the Department of Chemical Engineering, we have learned about 10 experiments where we have demonstrated each of the experiments in the FPM laboratory, and we have demonstrated 8 experiments in the CRE laboratory. So this time we also have our student volunteers to present before you a new experiment, the discharge through notches. We are going to learn about the experiment discharge through a triangular notch, and the aim of the experiment is to determine the coefficient of discharge of a triangular notch. So in this case, we are going to find out the coefficient of discharge, which is equals to the actual discharge divided by the theoretical discharge. So to find out the actual discharge, we need the length and breadth of the collecting tank. So once we have the length and breadth with us, we can find out the area of the tank, right? So in this case, once the water fills up, so we will have the initial level and the final level. So the difference between the levels is given by capital H. So in this case, we will keep constant. So suppose we keep it constant at 5 centimeter. So in this case, we will see the time required by for the water rise in the tank. Okay. So for 5 centimeter rise in the tank, we will see the time taken. So in this case, we can find out the actual discharge. How? The actual discharge is given by the formula, the area of the tank into the height difference, which is capital H, divided by the time taken, right? So we have the area, which will be constant. Then the capital H, we will keep that constant at 5 centimeter, and we will see how it is changing, right? How the time is changing. So at different values, we will have the actual discharge. Now to find out the theoretical discharge. In case of a triangular notch, the actual discharge is given by this formula. So this formula is 8 by 15 into root over 2g into 10 theta by 2 into h, capital H to the power of 5 by 2. So in this case, g is the constant, which is the acceleration due to gravity. Theta is the angle of the notch. So we are taking different angles, so that we need to use it here, and then capital H. So to find this out, so if this is a triangular notch here, so we know the depth of the tank, right? So once we have these values with us, so for different levels, we can find out the H value, right? Because H is nothing but the difference between the levels. So the initial level and the final level. So for different points, we will get different H values, right? So once we have this H value with us, we can find out the theoretical discharge. Now, similarly, we can find out the theoretical discharge in case of a rectangular notch as well as a trapezoidal notch. So, in case of rectangular notch, it is given by this formula. Let us see that. So, it is given by 2 by 3 into root over 2g into capital B into h to the power of 3 by 2. Okay. So, where B is nothing but the breadth of the tank, right? And we have h with us, right? So, this also can be conveniently found out, and the actual discharge will follow the same formula, right? So, we can very easily find out the coefficient of discharge for different notches, okay? So, when it comes to the trapezoidal notch, in this case, the theoretical discharge is the summation of the theoretical discharge of a triangular notch and the theoretical discharge of a rectangular notch, okay? So, that also can be found out. So, we can very conveniently get the coefficient of discharge for all the different types of notches, right? So, very simple. In this way, we can find out the coefficient of discharge for different notches.
Welcome to Fluid Particle Mechanics class. Today, we are going to perform an experiment named Discharge to Notches. The aim of this experiment is to determine the coefficient of discharge of V notch or a triangular notch. So this is the overall experimental setup, and here we have a motor, a pipe connected to a wall, and this pipe is connection to the notch tank. This is known as a notch tank. This notch tank is connected to a notch wall. This is V in shape or triangle in shape. So this is known as V notch or triangle notch. And here we have a depth gauge. And then this is the experimental setup for actual discharge. And then we have a piezometer and a scale to determine the height of the measuring tank.
The procedure for flow through notches. Here in this experiment, we'll have a V notch here, which we have to connect to the notch tank, and then we need to switch on the pump here by switching on this motor. Then we need to vary this valve so that we can change the volumetric flow rate. When the water is connected to this rectangular tank, this tank is called as notch tank. And here, when the water is attained to a steady state, we need to measure the depth of the water here. And then with the help of this depth meter, and then for finding the actual discharge of water, we need to take the rise of 5 centimeters and measure its corresponding time. To complete this experiment, we need to do this in 3 or 4 sets. We can repeat this experiment by changing different levels of water. It's just done by changing this valve through which we change the volumetric discharge, and switch off the pump after the experiment.
First, we should fill this tank. Let me show you. First, fill this tank completely. Now we need to open this valve so a little bit. Okay, now if you see a steady state is obtained here, so let us measure the depth of the water from the notch wall. By adjusting the depth gauge, we can see the depth.
So basically here we measure the difference between the level of the water, between the depth of the water of the notch and the water here. So we will get the reading from here and measure the reading. Reading is clearly 13.4. And we will subtract the initial depth, initial height of the notch, that's 9.6 centimeters.
Okay, now let's measure the actual discharge. Stopwatch. Phone is color. Okay, first we need to close this wall and open this tank. For every 5 centimeter rise, let us start. Okay, we got up to 0 to 5 reading. The time is 15.31 seconds. Again, we open this wall and let this close. And we will
Change the flow rate.
and now change the flow rate and wait for this to attain a steady state. Again, measure the depth of this height of the water from this gauge, and it's around 15.3 centimeters. So the height of the water level is 15.3 minus 9.6. And now again we need to measure this tank to get the actual discharge. So first, close this. And again. For 5 centimeter rise, we got 7.23 seconds.
Coming to the observation part, so we know that the coefficient of discharge is the ratio between the actual and the theoretical discharge of water flowing through the tank. So in this case, we will be using two tables. So in the first table, we are going to find out the actual discharge, and in the second table, we are going to learn about the ways in which we can find out the theoretical discharge of water flowing. So in the first case, if you can see here, we will need the ending of the notch, of course. So the ending of the notch will be there. So we will have two levels. So one will be the initial level and one will be the final level. So the initial level is given by H1 and the final level is given by H2. So the head over the notch is given by capital H, which is nothing but H2 minus H1. So it is the difference between the initial and the final level. So here to find out the actual discharge, we will need three parameters. So one is the area of the tank. So the area of the tank can be conveniently found out by using the length and breadth of the tank. So that is given to us. So that will be used to find out the area of the tank. Then we have the height. Okay. So height is given by capital H, right? And time. So what is time? Time, sir, is the time needed for the water to flow through the tank. So the time taken for the water rise in the tank will be given by T, which is in seconds. Okay. So in this case, we are going to measure H1, H2. So this will be in centimeter, of course. So in the first case, to find out the actual discharge, we are going to keep capital H, right? That we have to keep it constant. So in this case, the H is kept constant at 5 centimeters. So we find out the actual discharge through this formula, which is actual discharge equals to the area of the tank into the height divided by the time, right? So when we do the model calculation, we will need another column here, which will give us the actual discharge. Okay. Now to find out the theoretical discharge, in this case, the theoretical discharge is given by some parameter. So in this case, it is given by 8 by 15 root over 2g. So g is nothing but the acceleration due to gravity, which is constant, right? And then theta by 2. So theta is the angle, and here capital H to the power of 5 by 2. So in this case, if you observe, in case of a triangular notch, so we will have a, this level will be varying, right? So there will be one point at which, it will be the initial level, right? So that is given by H2 here, right? So that is kept constant. So here, that is 9.6, right? And we see how much H1 will come to. So H1 will be taken for at different points, right? And likewise, we find out the head over the notch. So once we find that, we have these values with us, and we use it to find out the theoretical discharge, which will be again found out in the calculation part. So for this 3 points, we'll have 3 different values. So once we have this actual discharge and the theoretical discharge with us, we find out the average for both the cases, and then we find out the coefficient of discharge. As I already have said, that it is the ratio between the actual discharge by the theoretical discharge. So we will get these values, and then we find out the average of this. So this is how we go about in the calculation for this experiment.
So I hope you all have gained some knowledge on the experiment to find out the coefficient of discharge through different notches. So we shall meet you again in another experiment in the laboratory. Thank you.
La 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 li la 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 li la 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 li la 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 li, la la la. La 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 li, la la la. La 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 li, la la la. La 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 la.